queen and half of them take off to go find a new home. And that's how they replicate. They find a new home. And so they're going out. They just find a tree or some place to hang out, literally hanging out while scout bees are looking for a new home suitable for them to move into, like your attic or a hollow of a tree. And so the rest of the colony is staying there waiting for these scout bees to come back and say, hey, I found us a new home. And they'll move on in there. And we'll actually talk a little bit about that later on. It's incredible if you see bees. Now, when I tell you about bees, or when I mention a bee, what's one of the first things that come to mind?
Honey.
Honey, of course. Honey is one of the first things that comes to most of our minds when we think about bees, because as we all know, bees make honey. You know that, I know that, Pooh Bear knows that. They make honey, and we love honey. Anybody like honey?
I love honey.
All right. There's very few things on this earth that I enjoy more than a good piece of cornbread with honey on it.
Well, I don't know. Honeycomb, isn't that supposed to be good if it's still got honey on it?
That's very good. Honeycomb is very good. I love honey. I was raised on honey. My kids were raised on honey. In fact, if you were to ask my son Caden, what's the one thing he wants to eat for lunch? He wants peanut butter and honey sandwich. That is his absolute favorite thing. I can get him anything else in the world, but he wants peanut butter and honey. Go for it. It's cheap. All right, I'll take it. But we think of honey because bees make honey. And everybody, you know, almost everybody likes honey. It's a very sweet thing. In fact, in the ancient times, it was one of the sweetest things that they had. And it's mentioned about in Scripture oftentimes, like here, for example, in Psalm 119, where it says, how sweet your words taste to me. They are sweeter than honey. So the psalmist here wrote, and he knew about honey. He knew that they were sweet. But he's saying to God, your words are even sweeter than honey. So Scripture, in multiple places, it talks about honey. And honey has a lot of beneficial properties to us besides just the taste. Yes, we enjoy the taste of honey and it's good, but real, genuine, you know, pure honey has a lot of health benefits that many people don't realize. And I would even say that we're rediscovering nowadays about the beneficial properties of honey. People in the old times, in the ancient days, you know, they knew about it. We now, with our modern medicines, are rediscovering that honey has a lot of beneficial properties, I believe, put there by God for a reason. Let's talk very briefly about some of these beneficial properties and some of these uses for honey. Here's a list of lots of different properties honey has. It has active beneficial enzymes. It's full of antioxidants. It has vitamins, it has minerals in it. There's antiviral properties to honey. There's antibacterial properties to honey. It has anti-inflammatory properties, and the list goes on and on and on. There are so many various uses for honey, you know, rather than simply putting on your piece of toast and eating it in the morning. Lots of benefits, like you see here. Let's see, benefits of raw or real new natural honey. It boosts endurance, reduces muscle fatigue. You can see as you're looking down the list. It's an antiseptic, antimicrobial, promotes healing, contains vitamin B12. It's used for burns, and if you go down the list, you see ulcers, you see hay fever, you see things like, you know, diabetic ulcers, various properties that honey intrinsically has within it that we can use for various things that I believe God has given us. He created all these things, and He created it for our enjoyment, for our use, and there's so many things in honey that we use it for. And more recently, in the medical field, we begin to even discover the properties and the benefits of honey, even in the medical field, for various things, including burn treatments and ulcers, and things that just won't quite heal up properly. We're finding that honey, literally putting honey in a bandage as a compress on a wound, actually promotes the healing, sometimes better than lotions and ointments and creams and medications do. And a true story that hits close to home for me, my grandfather actually, he passed away a few years ago. He was about 89 years old, but for the last few years of his life, he actually developed a sore on his leg. And he wasn't diabetic or anything, but he just had a sore on his leg that, you know, about the size of maybe $0.25 to $0.50, that would not heal up. I mean, for a couple of years now, I think it was. This thing wouldn't heal, and he went to the doctor, and they had, you know, they treated it, they put, you know, different ointments on it, different medications. They would change out the bandages regularly, but it just wouldn't quite heal up properly. And then I don't remember if it was him or the doctor he was with that had the idea, let's try this special honey bandage that they make. And I think it was actually his idea. And so he actually told the doctor, and they got a hold of it, put it on his leg, and he said within a matter of weeks, the outside edges of this wound were pink, you know, like with new growth, and sure enough, this thing closed back up and healed by honey. I mean, just using that, something in the honey, the properties in there helped bring about a healing, almost like a medication. And so it's incredible that nowadays, like I said, we're realizing in the medical field that honey, you know, this meta honey you see here, wound and burn dressing, they're actually using pure natural honey in place of many medications and various things that they're using, because it does, in fact, help promote that healing process. And it's something that we're kind of now rediscovering, I would say, because the ancients, they knew about the beneficial properties of honey. They would use it for wound treatment. They would use it for their food. They would use it for endurance. They would mix it, you know, and they would keep it with different foods and stuff for long journeys or for battles. Honey was very important in the ancient world to the Romans and to the Greeks and to lots of civilizations that had this honey. They would use it for various purposes. In fact, even the ancient Egyptians themselves were well known for collecting and using honey. As you can see here in this picture from an Egyptian tomb, you can see him collecting the honey and the honeycomb and the bees all along the side there. Egyptians were into beekeeping. They would collect and they would store this honey, and they would use the honey for various things. They would make drinks out of it. They would make certain foods out of it. They would actually use honey as part of the embalming process. So when the pharaoh died, he was embalmed, and honey was used in that process. And then also they were stored, there's honey stores where they would store this honey in the tombs with the pharaohs. Honey was so important to the Egyptian culture, they actually used the honey bee in their Egyptian hieroglyphics. It was an important animal to them. It was an important feature, so much that they used it in their hieroglyphics, almost like we would use something in our alphabet. It was that important to them. And oftentimes with the ancient Egyptians, honey and honeybees were associated with life and the afterlife, as you can see here with the Egyptian Ankh, that symbol of life and afterlife. And so that's one of the reasons why they would bury the pharaoh with jars of honey. Now, an interesting thing about honey, some of you might know, honey never spoils. It never goes bad. It sometimes crystallizes and firms up, but pure honey never spoils. In fact, that's why we've been able to go into these tombs, open up these jars of honey, and it's still edible. 3,000-year-old honey that they have eaten. And in fact, I think it's the Royal Geographical Society, there would have certain parties and celebrations where they would, you know, eat various things. They had some grains that they'd taken out of some of these tombs, and they ate some of them, but they had honey at one point, and they shared this honey amongst themselves, and it was still edible. It's amazing, the amazing properties of honey. It never spoils. It's one of the only foods that we know of that doesn't spoil, it doesn't go bad. It's incredible. Another thing that these guys did with the Geographical Society is they found some frozen woolly mammoths up there in Siberia. They took them out of the tundra there, they thawed them out, and they made woolly mammoth steaks out of them, which, from what I read, were not very good because they were spoiled, unlike the honey. They actually tasted really bad, but you get your opportunity to eat, you know, 1,000-year-old mammoth steak that's been frozen. And you might want to go for it, but from what I heard, I read, they did, and didn't go over so well. But honey did. It's incredible. Honey never spoils, it never goes bad. There's incredible things, even in Scripture, there in Proverbs 24, verse 13 here, you see Solomon telling his son, he says, "My son, eat honey because it is good, and the honeycomb," like you just mentioned, "which is sweet to your taste." He's telling his son, eat honey because it's good, and it's good for you, and it's sweet. There are so many great things in honey that come from these bees. Now he's mentioning honeycomb in here, and what I want to talk about for a couple minutes is this honeycomb itself. When you see a honeycomb up close and you see how it's made and the structure of it, it will blow your mind that these little tiny insects have the wisdom, have the intelligence to create such a complex structure, mathematically precise structure that is stronger and more stable and uses the area space better than any other shape known to man. Here's a close-up shot of honeycomb. And you can see they're all made up of 6 sides, hexagonal cells that are created, and they don't just start one place and then add on and add on. Bees oftentimes will start in multiple places, each of them making their own little area of honeycomb, and they just happen to fit together perfectly. The honeycomb is made up of wax that the bees make, and as they're making this honeycomb wax, they just create it from themselves. We'll talk about that a little bit later. but it creates these perfect six-sided shapes. And scientists looking at this have realized this is the best use of space, and it's one of the only three shapes known to man that actually will fit, interlock together, and be able to stack right next to each other. But this is the best use overall of space, total perimeter space, as well as strength in the cell shape. That's why oftentimes, if anybody works in the, making airplanes and stuff, what they've done a lot of times is they actually will use honeycomb-shaped cell structures inside the wings of planes made out of aluminum or whatever metal they're using. They'll use it because it's a strong support to that wing, but it's very lightweight. And they use that same six-sided honeycomb shape to it. But also, it creates a space where they can interlock together. Now, there are only three shapes that we know of that will fit together and can form without, being all jumbled up. The square, okay, the equilateral triangle, and the hexagon. The hexagon actually uses the most storage space inside there with the least total perimeter space. So you get the most honey that you can put in any shape known to man using this right here. How did they figure that out? If they made circles, you could have circles next to each other, but think of it, if you have like a bunch of straws gathered up, you have lots of spaces where the circles don't come together. So that's not a very good use of space. Only this shape right here is the perfectly most calculable space for size and for storage that we've ever come up with. They've looked at it mathematically and calculated all this and find out the bees got it right since the very beginning. Sounds to me like there was a lot of intelligence by a great designer that went into this. So the bees, they store in these honeycombs, they store their honey. They also give birth to their young. They put their eggs inside there and they grow and they hatch and they develop in there. The bees use this basically as their home to live in and to take care of. And so amazing things that the bees do with this. Another interesting thing about this honeycomb is when they build it vertically, and it has two sides on there, on each side, where you have the honey stores on one side and the same thing on the other. So it's two-sided, it's a vertically hanging piece of comb. And the interesting thing about this is these little holes in here are actually not straight out, but they're even at a slight angle, kind of like this, so that honey will not drip out and fall to the ground. So they're built perfectly, the design, the structure, and even the orientation to gravity, so it keeps it all together. And it's amazing design when you look at just how complex it is. And they're reusable. So when the bees pull out the honey, when they eat it, when they pull out the young, they clean it up, they repair it, use it over again. So they constantly are reusing these honeycomb cells, and it's amazing property. Now, one thing that we get from bees, we talked about honey. Another thing we also get from the bees is the beeswax that comes from these honeycombs. And beeswax is also an incredible thing. I love beeswax just almost as much as I love honey. I love beeswax candles and using it for various things like, anybody ever use Burt's Bees, like the lip balm? Okay. Well, Bert up there in Vermont, he had bees and he had a lot of beeswax, and so he said, hey, let me start a company. And he doesn't own it anymore because he sold it, but beeswax is in that lip balm, and in fact, most natural lip balms contain beeswax, and it's one of the bases in there. Beeswax is incredibly important to our civilization, our society, because for thousands of years we've used beeswax to do things like make beeswax candles. And I actually have one tonight. I'm going to pass this around, kind of a little bit of show and tell. And take a smell. You can smell the honey. This is a pure natural beeswax hand-dipped candle. You guys can take that and just kind of pass that around. But beeswax candles have been used for thousands of years. We've been collecting that beeswax, and if you smell that candle, it smells just like honey. I love it. In fact, I keep one by my bed where I'm sleeping. I don't light it usually, but I can still smell it on my nightstand. I love the smell of it.
Oh, that's nice.
Isn't it?
Oh, wow. I buy all kinds of lotions and things that have beeswax, and they don't tend to separate like some of the other natural ones. Yeah. They stay put, they stay good.
Yeah. Beeswax is a very very good wax. When you look at the world, we have beeswax, we have some soy waxes that we've got now. We have the paraffin wax, that we get from oils and refinement and stuff. But interestingly enough about beeswax burns brighter, it burns longer, and it has a better light color to it than other normal waxes. It also burns cleaner. Beeswax doesn't put off, toxic fumes and smoke particulates that normal paraffin wax candles do.
Right.
Beeswax actually will burn longer, and it will stay longer and brighter. So a beeswax candle actually burns brighter than standard paraffin wax candles do. And we've been using it for thousands of years. In fact, many places now, especially places like Orthodox churches where they use candles and stuff in part of their ceremonies, they actually only will use beeswax because it's brighter, it's more pure, and all those sorts of things. But we get wax from that, and we can also from that wax create things like the lip balms and lotions and various things that we do with cosmetics or healthcare things from that beeswax. So again, I look at this and I say, God, you are an incredible God. You gave us the bees, they gave us honey, and we also use this wax. We've been using beeswax for thousands and thousands and thousands of years for all sorts of properties. We use beeswax in sealing furniture sometimes if you're a woodworker. Sometimes you use beeswax to bring out that shine, and sometimes nothing brings out that look or that finish like beeswax. We've been using beeswax to seal things. In fact, the Anasazi Indians that lived in the Grand Canyon, there's a place down there, they have a valley where they would store up all these grains, and they would take these grains and they would actually seal them with beeswax as a preservative. And so it's an amazing way to seal things and to keep the water, keep moisture, keep critters out of it. It's incredible. I just look at it and say, God, you did something pretty cool there with the life of the bee. So this wax that the bees have, the bees actually make it, the wax is discharged as a liquid along their sides, and it hardens into small flakes or scales, and it sits in these little wax pockets. And then the wax is transferred to their mandibles where they chew it up, and then they kind of chew it up, make it all soft and compact, and then they either hand it off to somebody who's making the wax cells, or if they're the ones doing it, they'll make it in there, but it just naturally grows as a liquid and then hardens up. So there's glands on the sides of their body where this wax just comes out, and then they say, oh, let's take a piece here, let's take a piece here, let's chew it up, we'll put it together, here you go. Amazing. How did they learn how to do that? How did the bees learn how to create all this wax that they need for their homes to place their children in so that they could actually have a home to begin with, so they could have a population of bees? Wait a minute, you see the problem room coming here. So they suddenly, after millions of years of evolution, figured this out.
Came from a
Or
tadpole.
not. Or we have a very highly intelligent creator God who gave us amazing things like these to proclaim his creation. I love looking at this. And you can see here are the wax areas that they have on their sides. 4 pairs of glands that just produce it as a liquid. The water kind of goes away, evaporates, and there's a waxy substance that's left behind, and they collect it for use. Amazing. So we have honey from bees, we have wax from bees, we also have something else that we're now really discovering benefits and uses for, and that's called propolis. Anybody heard of that word? All right, some of you who studied bees have heard of propolis. Propolis is kind of it's kind of like the glue of the beehive. What propolis is, bees when they're going out and foraging, they're collecting the nectar, they're collecting the pollen. They also collect plant and tree resins. So they'll collect resins, they'll collect saps, and they'll come back and they'll mix it together with some of the pollen and various things that they have, and some of their beeswax. They'll mix it together, and it forms a very sticky, tacky glue. And they'll use this propolis glue to literally glue things together inside of their hive. So if they have an area, for example, on a commercial beehive, if you have a crack in a corner somewhere where air or light is coming through, they will actually fill that up, almost like caulking that you'd use to fill and patch drywall or something. They patch it up. In fact, this is the top of a beekeeper's hive, and he's had to pry this away to actually get into there and start working in the bees. And you can see the bee frames that are running along there. It's kind of a pain because you have to get a tool to pry in there and pop this up because it's a lot like glue. At 68 degrees and higher, it's tacky, it's resinous. But below 68 degrees, it's actually very firm and very, very hard. And so either way, it's still very difficult to kind of get in there. But this propolis that they have there is an amazing thing that the bees have. And here's another picture, kind of close up. You can see as they have to pull it away almost like taffy. You pull, and then snap, and then you can open up. And so that's different plants and tree resins and various saps and things that they collect together, and they put it together. And interestingly enough, this propolis contains some amazing beneficial health things even for humans. That's why we've taken bee propolis and we've made it into little pellet forms, and you can buy it at the health food store and you can eat it. And I have some in my house. It actually tastes pretty good, and they say it's really good for you. There's a lot of benefits to this propolis. A lot of things that we get. It's a very, very promotes healing. It's an anesthetic, anti-inflammatory, all sorts of things. In fact, here's an interesting thing. Researchers from the University of Chicago Medical Center report that doses were given to mice that had prostate tumors, and the tumor growth slowed by 50%. I'm giving them this propolis alone. So there's something in there that the bees are collecting, that they're creating together, that give amazing beneficial properties. In fact, so much so that we're now looking at it for things like toothpaste. Colgate makes a brand of toothpaste called Colgate Propolis, which has the things in there that help our gums heal and provides a lot of cleaning properties, and it's amazing that they're putting it in there. I haven't seen this on store shelves yet or somewhere, but I'm going to go look for this or order it. It's pretty interesting. I wonder if it tastes like honey, though. We'll have to see. Colgate Propolis, amazing things. So we've got honey, we've got the beeswax, we've got the propolis, and then there's another thing that bees make called
Royal jelly.
royal jelly. How many of you heard of royal jelly? How many of you have ever taken royal jelly? All right. You like it?
I do.
All right. Why?
Well, I used to use it for my face,
Okay.
and then but I also had it in the pill form too.
Yeah.
And it just makes you feel good.
Lots of uses for what's called royal jelly. Now, what royal jelly is a special, it's a special food that the bees make that they will give to all their little baby bees when they're first born. They give them a little dose of it to kind of get them kick-started into life. And then whenever they want to make a queen bee, they actually will bathe her in this royal jelly and just feed her this royal jelly until she becomes a queen bee. And through this process of only feeding the special food alone, a queen bee develops from a normal worker bee into the larger, much larger, and able to reproduce, and it's a grand queen bee simply from this food alone. That's incredible. It's nothing more special than that. It's simply this food that they give to this bee that they create, and they'll place in there. And here's a queen cell, you can see. Right. And they will give these baby bees, as they're developing, royal jelly, and they will develop into queen bees simply from eating this food. And you think that there's something special or something important in there, won't you? Sure enough, when people have looked at this, and here's a queen bee coming out of her cell. Pretty cool. We've seen so many properties and beneficial things with royal jelly that they sell it in capsule form. They use it for special lotions or things. It's amazing stuff that's in there that the bees will create and feed to their young, and it kind of gives them a kickstart, but then again it turns normal bees into queens. And so there's been a lot of talk about important things with that royal jelly, the benefits that it gives even us as humans, because it's so full of nutrients and things like that. It's incredible. Looking at the life of the bee, did you ever know that they could create so many beneficial products for us to use? I mean, honey, beeswax, propolis, royal jelly. It's amazing. Now, speaking of queen bees, let's talk about the difference of some of these bees that there are. In a beehive, you only have 3 different bees. You've got the standard worker bee, which is the one that you and I are familiar with. That's the one that we see by the thousands. And in the beehive, you have a few drones over here, which may only be a few hundred in the beehive. And then you have usually one single queen bee whose job is to make all the other baby bees. And so in this beehive, that's what you got. Typically, you only have one queen at a time, unless they're getting ready to split off, and she'll only be there shortly. She needs to be, because they'll fight each other. You have a few male drones who are there to reproduce with the queen. That's their only job in life. And then you have all the worker bees, which are all females. All the female worker bees do all the work in the whole colony, basically. Here you can see them on the honeycomb. The queen bee is larger, so you have a much larger back end here. The worker bee, smaller than the other ones. And then a big fat drone bee here, who's not quite as long, but pretty fat, and has very large eyes, you can see. He's lazy, okay? We'll call it what it is. Pretty interesting. Well, all of these bees are pretty much born the same way, except for the queen who's fed the special food. They are all placed inside of the honeycomb, inside these cells right here. And you can see on the right, you can see these little individual pieces that look like grains of rice. Those are tiny little bee eggs. And they place those eggs right there in the middle. They squirt a little bit of this royal jelly you can see around here. And the bees began to grow, and they develop from eggs to larvae. And over on the left here, you can see them developing into these larvae. So they continue to grow from egg to larva, and then they continue during the development process to develop into their pupas. And so they develop and they grow, and then at a certain point, the bees go and they put a cap over the top of this while they develop fully mature and ready to be useful to the hive. So they'll put a cap, they'll let them develop, they'll let them grow. And you can see here, you've got some that are about to be capped. This one's about to pupate, turn into a pupa here. This one, yeah, you can see almost is fully capped. And inside there, the bees continue to develop, almost like in a cocoon. It's like little tiny bee wombs everywhere, all throughout the whole honeycomb. But the bees stay in there, they mature and they grow, till they get to this point where there are a pupa. And you can see here, in fact, there's an egg, larva, developing into a pupa, developing right here, just about ready to hatch as a mature bee. They will orient themselves upright, head out, ready to go outside. So here is the honeycomb. Here's the middle of it. So you have cells facing this way, and you have cells facing this way. In the beehive, it would be turned up this way, hanging vertically. But you can see the bees developing here. So some of these cells are used for birthing young. Some of them are used for storing honey. So they'll keep them collected in it. Some of them are actually used for storing pollen that they will use throughout the year as well. So they'll go through this whole process of development, and you can see the life cycle and the stage of them. For a queen, you can see the queen, the worker, the drone. Each of them are an egg for only 3 days, and in the larval stage for the queen, you can see is 5.5 days. Pupal stage is 7.5 days, and by 16 days, she is fully developed, ready to go.
Really?
Which is very interesting, contrary to the drones on the other end, which are 3, 6.5, 14.5 days, all the way up to 24 days to be fully developed. So it's interesting that the largest bee in the entire bee colony, the queen, only takes 16 days to fully develop, while the drones take 24 days to develop. Why is that?
What they feed them?
It's that special food, exactly. It's what they feed them. Why you tell your kids growing up, eat this and you'll be big and strong one day. Well, look at the life of the bee. It's very true. The working bees take 21 days to fully develop. The drones, 24 days. But the queen, only 16 days. So although she has much more mass to put on and grow larger and more developed, it takes her less time because of this food that she's eating. It says to me a lot about the food that we eat and how it really affects us too, wouldn't you say? Trying to eat healthy, there are some benefits to it. All right, moving right along here. Here you can see on the beehive comb, drone and worker cells. You can see over on the outside edges here where the drone cells are, they're a little bit larger, and they have a raised cap because the drones are larger bees. And here in the middle are the worker cells. And in a beehive, you may have anywhere throughout the year from 30,000 to 60,000 bees in a colony at any one time. And only maybe sometimes 300 to 500 of those bees will ever be male drones. All the other tens of thousands of bees that are there are all going to be these female bees, and all of them worker bees except for that lone queen. Pretty interesting, and they put their honey in there, they put their young in there, they continue to develop throughout their lives. Now these queen cells are very different from the other two cells that we just talked about. The queen cells are larger and they're bigger because they have to accommodate a larger bee as she's growing up. Now over here you see what's called a supersedure cell, where the queen bee would, sometimes they would raise a new bee to supersede the old queen. In other words, kick her out of the hive and put a new queen in place. When the old queen stops producing like she really should, then they decide, hey, I'm going to get a new queen in place, we'll remove the old queen. So they develop a set of new queens. In fact, they'll sometimes develop 3 or 4 or 5 of them at a time. And then whichever one of those hatches first, then that will be the new queen, or whichever one, if they hatch at the same time, and they may fight to the death, the strongest one survives. Other times, as we talked about, they'll create a swarm cell when the beehive is getting ready to swarm and to break in half and to split off. And so half of the bees will take the new queen and go and find a new home, and that's what that cell looks like right here. And so as a beekeeper, you kind of look at that, and sometimes you don't always want them to swarm, because if they swarm, there goes half of your bees and half of your production, and you have to wait for the queen bee to make many, many more thousands of bees. Or sometimes you can take that cell and put it in a new beehive box, and you can add some bees to that, and you have 2 colonies now. But you have to catch it on the right days.
Yeah.
Remember those days? 16 days for that bee, so you have to make sure you get it on that right day. So that bee gets out and takes half of them, there you go. There's times even the bees can swarm, they'll go out and you'll see them in a tree in your backyard still, and you can go and still collect them, put them back in a new hive, and continue on with that. Alright, moving right along here. Let's talk very briefly about the queen. She is the boss of the whole place. She takes care of all these bees. Basically her only job is to lay eggs. All the other worker bees take care of her, they feed her, they bring her everything she needs. She can live anywhere from 2 to 5 years. Now, that's kind of a lot when you think of an insect, right? I mean, most bugs and insects only live for a few weeks. But these queen bees, because they're taken care of, because of the food that they continue to eat, live anywhere from 3 to 5 eggs, or 3 to 5 days, and can lay up to 2,000 to even 2,500 eggs in a single day. That's a lot. Think about that. Over 2,000 eggs in a single day that they can continue to lay each and every day during the height of that season. One of the ways that the queen bee kind of keeps control of all the other bees is through using pheromones, different scents that she produces. And throughout her life, she'll produce a queen scent which tells all the other bees that she's healthy, that she's strong, that she's reproducing, and keeps them loyal to her and keeps them there. Now when she gets older, she stops producing as well. She stops laying eggs as much, and she also stops producing this scent, this pheromone as much. And that is the signal, that's the trigger to the worker bees to say, hey, we love you, mama, but we got to get a new queen in here. And they will actually produce these new queens. Now, unlike the other bees, the worker bee, she has a stinger that doesn't have barbs on it. So it's reusable. So she can sting multiple times, but she usually only uses it to fight and to kill other rival queens. So, you know, the one bee that's in there that has a reusable stinger, you don't have to worry about it too much. Wasps and hornets, you know, they have reusable stings, and they'll get you much more than the queen bee ever would. But she uses that to kill rival queens. It doesn't have barbs, it doesn't pull out part of her when she stings, so she's able to reuse it. And then we have the drones, these lazy boys. The drones, they develop just from eggs just like everyone else, but they're larger than the workers. They have very large eyes. They're the only males in there. And they're mature at 2 weeks, and their one function in life is to mate with the queen. And as soon as they do that, they die. So what happens is they'll fly up into the air, about 300 feet into the air, doing this great bee dance with the queen. And she'll put out pheromones that says, now it's time for me to mate. She'll fly into the air. These other bees try to fly up to her. So 300 feet is pretty high. And one of the reasons she does that is because she's wanting to see which one of these drone bees can actually fly up there, make it up to that height, and stay with her in order to mate in the air. If there are drone bees that are weak or that aren't very healthy or can't fly very well, you don't want them passing on their DNA to the rest of your bee colony anyways. So they might not make it up there. So she flies so high into the air so that the strongest of all the bees that are there will be able to mate with her. Once they do, they die. And they place into her their sperm sacs, which stay inside of her and actually stay living inside the queen bee for all these years that she's alive. She takes that and she actually stores it inside of her, and she never has to mate again. But she will mate with multiple bees, and multiple bees will deposit their sperm sacs into her. She stores it in her special pockets that she has inside, and she never has to mate again. The bees that do mate with her, they die. And then all the other boys, they're not so lucky either, because at the end of the season, once winter starts to set in or they begin to kind of get into bee hibernation, they will be forced out of the hive, and they also will die. So all these boys who have this lazy, fat life sitting around doing nothing, letting all the ladies work for them, your time is coming. Yeah. They don't have any stingers. They don't need them. They just sit around and eat food and wait for the queen to say, now it's time. And so they all die off. So not such a good life for the drone. Then we come to the worker bees, who are all female, but not really fertile. They usually don't ever lay eggs, but if they do, they'll become drones because they're not fertile. There's anywhere from 20,000 to maybe 60,000 in a colony, so many of them. And these are the bees that you see flying around doing all the job, doing all the work. They only live, however, between 4 to 6 weeks in the summer. They literally work themselves to death, working so hard. Remember the queen bee, she lives anywhere from 2 to 5 years. These bees, during the summer when they're working, only 4 to 6 weeks. And in the winter time, when they're kind of sitting around not doing anything, they may live anywhere from 4 to 5 months at a time. However, it's still not a long time when you think about the queen bee's life. These are the ones that will sting. These are the ones that have barbs in their stingers. And so when they do stick it in something, they plant it in, They can't pull it out without pulling out part of their backside, and when it happens, the bees die. So it's a very costly means of protection for the bees. They don't really want to go after you and sting unless they have to, because that means their own death. So sometimes they will have other means of protection and taking care of the hive. But they do lots of jobs, several functions throughout their lives, including what you see right here. They start off, they're kind of nurse bees, and they're taking care of the hive. They're cleaning out honeycomb cells. They're helping the newborns. Then they become a house bee, and they kind of do some of the other stuff around there. They build the honeycomb. They're the undertakers, so they get rid of dead bees or anything else that gets inside of there that might die. They'll get rid of it. Things that are larger that they can't quite drag out, they will actually, it's really interesting, they will cover it in a layer of propolis. And we talked about that propolis, that sticky glue. One of the things, amazing properties of propolis is it's very, very antibacterial and antimicrobial. So they will actually coat sometimes the inside of their beehives in this, and it's almost like creating a sterile, clean room. But if something like a mouse or a large insect that they can't quite remove, if it gets into the hive and it dies, so they sting it to death or something, if they can't remove it, what they will do is they will actually create a whole covering of this propolis around this dead animal to keep it from putrefying and spreading disease throughout the colony, and it actually does a very good job of it. The properties in this propolis are amazing, so they'll use that. They're the undertakers, and they'll take care of all the stuff. They will work on ripening the honey. And what that is, when you take that nectar and you kind of evaporate it to a certain point, like sucking it in, and then pushing it back out and letting the air evaporate, sucking it. They do this process constantly till a certain point, and then they put all that nectar and that kind of very watery honey into this honeycomb cell. And then what they will do is they'll get on top and they'll fan their wings, and that fanning motion evaporates the rest of the liquid out of the honey until it's to a certain point that they know, and then they will cap it entirely in wax, sealing in the moisture, protecting the honey that's in there, and they'll take care of it. So they do the ripening. They help keep track of the temperatures inside there. Is it too hot? Is it too cold? Bees, no matter what time of year, they keep basically the same temperature throughout the entire colony. It could be the dead of winter, and in wintertime they will vibrate very quickly, and they will generate heat inside this honeycomb, inside this hive where they're living. In the winter, it stays warm because of that. In the summer, when it gets too hot, they will actually fan their wings, and they will orient themselves in a certain direction to where they will get a current of air flowing through there, cycling air through there, and there will be bees standing outside waving in fresh air, and they just constantly do this, and it's amazing how they just know how to do all of this. Then they go off into house security, where they're taking care of the beehive, protecting it. Then most of their lives are spent as field agents, going out there and collecting the propolis, collecting the nectar, collecting the pollen, collecting all the stuff that they need for their home. And they will work on that, and they will continue to do that until they literally work themselves to death in the summertime. All right. One of the things that these bees do make, and one of the ways that they communicate, is through these pheromones that we talked about. Not only does the queen make pheromones, but all the other bees themselves make pheromones, these scents that tell the other bees what's going on in the life of the bee colony. They have this nasonov gland at their back ends that actually produces this pheromone and puts it into the air. And they will fan themselves, like you can see here. They will stand in there and they will stick their butts up in the air and they will fan themselves, and they will put this pheromone into the air, and it tells the bees lots of different things. For the young bees who are just learning how to fly and go to different flowers, it produces a scent that says, hey everybody, this is our home. Not the beehive next to us, but this one is ours. Each beehive has their own special scent, and they go back to it. They initially learn how to find their home because of the scent. So they will stand at the door, they will fan their wings to help air condition. They will also fan their wings to disseminate this pheromone scent into the air so they can attract the bees to come back and land at home. So they'll put out this scent, and that's one of the things that they'll do. In fact, when you see a bee swarming and you see them, stuck on that tree like we saw earlier in the video, there are scout bees that are going around all over the place looking for a brand new home, looking for the right size, the dimensions, a little entrance, all the different things that it needs. Once they find a place that's suitable, they will go inside there and they will spray this pheromone all inside the house. Then they will go back to the other bees and say, hey everybody, I found us a new home, the promised land, flowing with bee milk and honey. So then they will take all their bees and they will go back and they will find this place. And the scent tells all the other bees this is home. Now, surprisingly enough, we know what that scent smells like. It smells very much like lemongrass. So I'm going to pass this around. Don't open it, because if you do, you'll get lemongrass oil on your fingers, and it will smell like that for 2 days. But you can smell it. We use lemongrass oil inside new beehives because it mimics the scent, this pheromone smell that the bees themselves make. Or you can take a beehive box and you collect a wild swarm by, creating a little box here. Just don't open it up, because you might spill it and it's not going to be very fun. But we'll put it in a box, and you can put lemongrass oil in there, and sure enough, bees themselves that are looking for this new home will see that, will pick up on that smell, and they will begin to make that their new home. And you can go and collect a beehive, a bee swarm from the wild, simply by putting lemongrass oil and having the right dimensions inside the box that they really gravitate to. So it's amazing the pheromones these things put out tell the bee colony various different things. The queen puts out her queen smell, which tells everyone, hey, the bee colony is doing good, I'm doing good, don't kick me out yet. She also puts out the smell that says, hey boys, let's go and mate, and so we can have new children. So she'll put that out, and that's a signal. Then there's the orientation pheromone we talked about, which tells the bees where to go and that this is their home. Then there's the alarm pheromone, which is basically saying, hey, there's an intruder, or there's danger here, everybody get ready and get outside of the hive, because we need the guards to get out in front. Surprisingly enough, this smells like bananas. Yeah, so that's why as a beekeeper, you don't eat bananas while you're taking care of your bees. True, very true. You don't eat bananas. You don't have banana-flavored candies or gum, because any of that, the bees can smell that and come flying towards that source. So this alarm pheromone we've discovered, to us at least, smells like bananas. And so you don't want to have bananas when you're taking care of bees. It's been known to rile them up and stir them up. Then you have the you've got stung pheromone, which is what happens when a bee plants its stinger in your skin and it pulls away. The back end of that stinger continues to pump the toxins into you, but it also produces a pheromone wafting off of it that tells all the other bees, hey, there's the bullseye, go after it. And so it alerts all the other bees that, hey, I gave up my life to take care of this intruder, why don't you come and defend my honor and do the same thing? So it attracts the other bees to sting you. Interestingly enough, one of the best tools for beekeepers to use, if there was one go-to tool that you need, it's not the the bee suit. That's great, it keeps the bees from stinging you. It's not the gloves that you use. I know many beekeepers that don't use a bee suit, that don't use gloves. Bare hands go in there, reach into the colony, work, they know how to do it. But the number one tool that you really need to use as a beekeeper is your smoker. Now the smoker, you put some, some plants in there, some pine needles, whatever it is that you have, wood chips, and it produces a little bit of smoke. It continues to smolder in there, and then you pump it with a bellows, and it pumps lots of smoke into the beehive. So when you go and you crack open the lid of that box and you shoot in a little bit of smoke into there, and what happens, the bees don't really sting you, they're very calm, it keeps them pacified. And when the bees start to kind of work themselves up, you kind of put some smoke in there, and they go back into their into their honeycombs, and they'll stay away from you for the most part. That's the number one tool, been used for thousands of years. The Romans used to use it, the ancient Egyptians used to use it. We've known it for thousands and thousands of years that smoke and bees, they work really well when you're using smoke against bees. Now, one of the reasons why we think the smoke is very effective against bees, it doesn't kill them, it doesn't damage them, but what we think one of the reasons it does is that it confuses the bees because they can no longer pick up those pheromone smells. So that smoke in the air produces a smell that kind of blocks their pheromones, so they don't send out that alarm pheromone, so they don't send out the you got stung pheromone. In fact, as a beekeeper, if you do get stung, what you want to do is you want to puff a little smoke over that area, and it stops it from stinging. It stops it from producing that pheromone. It still hurts, but it stops it from producing that pheromone and getting other bees to come after you. The other interesting thing it does is when you waft that smoke into the beehive, the bees dive down and they turn themselves face into their honey stores, and they begin to soak up all that honey. They slurp it up, and then they become very kind of fat and engorged. And then what happens for most of us on Thanksgiving Day after we've eaten our full meal? We're full, we're tired, we're lazy. Same thing happens with the bees. They become engorged, and actually sometimes engorged to the point that they actually can't push their stinger out. Their abdomen swells so much that they can't actually push that stinger out. But it also becomes very, very docile and relaxed. and they think it's because of they've kind of eaten so much of that honey, which isn't a whole lot to the beekeeper. It's not like you lose all your honey supply, but they soak it up real quick. And one of the reasons why we think it is because when the smoke goes into the beehive, the bees are thinking that there is a forest fire nearby. And so they're wanting to take in as much of that honey as they can in case they have to abandon the hive and find a new place to live and then, expel it back out to be able to use it. So it tells the bees, hey, there's a fire nearby. Where there's smoke, there's fire. So there's a fire nearby. Let's take as much honey with us as we can in case we have to get out of this place. And that way, when we find a new home, we'll have some honey already made to eat and to be able to raise our young with. So the bees will actually dive into there. When you put that smoke in there, they will consume some of this honey, engorge themselves, and it makes them very lazy and slow and docile. But also, it helps keep the bees from attacking you, and it blocks the pheromones. Amazing process.
Yeah.
Now, these pheromones aren't the only way that bees actually will protect themselves. Bees are very, very smart creatures, and I want you to see this video here about bees taking care of a hornet, which is many, many times their size. This is in Asia, where they have the giant Asiatic hornets. And I've seen videos of 30 hornets, 30 hornets decimating 30,000 honeybees. Now, the bees that they have here in Asia, they are the giant honeybees. They're the largest honeybees in the world. So they're pretty good-sized bees, but these hornets they have, as you see in this video, are much, much larger. And these hornets have reusable stingers, so they can sting the bees, but they also have very big mandibles, these big pincher teeth, that they will just literally bite the heads off of these bees. And so it's a problem there where we've had videos of them where 30 hornets, only 30, will wipe out an entire colony of 30,000 bees. But the bees have a way of getting them back, as you're going to see here in this video. It's amazing how they learn how to do this. Almost as if one mind, they're just creating this ripple effect, and you can see the beautiful pattern on there. As this hornet, this mimicked hornet, is trying to land on there, it just creates these patterns, and the bees just do it almost at the same time, somehow that they're communicating with each other to ward off. And that's not the only way that bees communicate with each other. We talk about pheromones, we see this here. But one of the most important things that we see in the life of the bee is in communication. It's a bee language that some certain bees tell other bees where to find food and what direction, how far, the quality, the quantity, all of this stuff. They communicate with each other in a language. And really it's one of the very few languages we've ever discovered in the animal kingdom that tells such precise details about something. They call it the waggle dance. And so what this waggle dance does is they will get in there and they'll start doing this dance where they waggle their back ends in the direction of their food source, and they'll take a little loop, they'll waggle again, they'll take another loop, and it points them in the direction of this food source. Now they use this in relation to the position of the sun. So these bees, some of the smallest and tiniest of creatures, are using amazing facts of geometry, maybe trigonometry. They're actually using this incredible design to be able to communicate with other bees where certain things are, like the food that they're looking for. And they will do this little dance, they will waggle, and they will point in the direction in relation to the sun. They will waggle a different way if it's a close distance, or a different way if it's a far distance. They'll bring back, samples of that food, of that type of pollen or that nectar from the plant or the flower, that they will actually be able to share with the other bees. And they will say, hey, let's get ready, let's go out here. And they will tell the distance, they will tell the other bees the direction, they will tell the other bees, if it's a lot or if it's a little, and they'll communicate with the rest of the colony the direction of where they're supposed to be headed. So in the colony, for example, if the sun is straight up and they're doing a 30-degree dance where the flowers are at over here, inside there they will go inside, and according to the direction and the position of the sun, they will do that dance at a 30-degree angle, telling all the other bees, 30 degrees over this way from the sun is where our food is at. And it looks a little something like this.
This honeybee is collecting nectar from a purple kufia flower.
Much more incredible than a stinger. These bees somehow, through millions of years of evolution, they somehow know that this giant hornet can only tolerate temperatures up to 115 degrees, and they themselves can only tolerate temperatures up to 118 degrees. So when they surround this hornet, they don't sting it, they don't waste their stingers, they don't kill themselves. They actually surround it in a bee ball, and they will generate enough heat to 117 degrees. 1 degree short of their own death. but 2 degrees higher than what this hornet can withstand. Only 1 degree separates them from death. They generate 117 degrees and will cook this hornet until it dies. Isn't that amazing? How did they learn how to do that, you suppose? You know, to surround something like this as an intruder and decide not to sting it, but instead to somehow generate heat. Amazing. So yes, the stinger is an important defense mechanism, but bees are so highly intelligent. They do many more things you never would know about. One of the things that we oftentimes take for granted with bees is the fact that bees are the largest pollinators of the plants and flowering fruits and trees and shrubs and anything on our world. Bees play such an important role in human existence throughout time because of the fact that they do pollinate. They take pollen from one plant and will transport it to another. You see, when flowers want to reproduce, they can't because they have no legs, they can't walk, and they can't get together.
Right.
So unless they rely on the wind to somehow waft pollen in a certain direction, they really can't pollinate without the help of another animal. And bees do, I would say, 90% of this work. In fact, there are certain plants on this planet that would not exist if it weren't for bees. They wouldn't be able to survive. There are certain plants that can only be pollinated by bees. They're so very useful that here in Southern California, people pay hundreds of thousands of dollars to bring in bees to pollinate their plants and their trees.
Almonds.
These are almonds, exactly. Almonds that grow here have to be pollinated, and they have to be pretty much pollinated by bees. And so an almond farmer will actually pay hundreds, literally hundreds of thousands of dollars to beekeepers to bring in their bee colonies by the tens of thousands to pollinate all of their trees.
There's no nectar in those flowers.
Yeah, they're looking for the pollen. They're looking for the things
That's all
that are
they
in there.
get.
Yeah,
There's no nectar.
not really, and that's what they go after. Now, the main reason why is because without the bees, the farmers would not get a very good yield of almonds. However, when you bring in bee pollination, you will get anywhere from 5 to 7 times the yield. Think about that. So when they bring in these bees, it's worth it to the almond farmer to pay out this money. And so beekeepers, I know of beekeepers that have gone out of the honey business and said, I don't want to raise honey anymore, it's too sticky of a job. I'm going to go in and I'm just going to actually make my money by transporting my bees around the country, and people will pay them money just to set their bees out in their field, do the pollination, collect everything that's out there, come back in, take them to the next place, and they will actually travel a circuit around the world. Almonds are one thing. There are many other plants that bees are very, very useful. In fact, we need them to keep our food alive.
There's some little bee in Madagascar that they didn't know about, and they shipped vanilla beans to Mexico to try to grow orchids.
Yep.
Well, they grew fine there, except they couldn't pollinate. And then somebody discovered this little tiny bee that pollinates the orchids, so they imported them from Mexico. And that's how the Mexicans can grow vanilla.
Yep, that's exactly right. In fact, I have a paper on that in my my computer bag over there talking about that. The vanilla bean plant has to be pollinated by this special type of bee. Bees do an incredible thing. They pollinate all these different things. In fact, they say 2/3 of what we put into our mouths are related to bee pollination. Whether it's the plants and the fruits themselves or the animals that we eat that are produced, from the plants that they grow on, that the bees have to pollinate. And it says right here, if you look up here, of the 100 crop species that provide 90% of the world's food, over 70 are pollinated by bees. So think about that. You go into your grocery store, without bees, 2/3 of the fresh produce would not be in existence.
Huh.
Everywhere from alfalfa all the way down to watermelon you can see in there. And sure enough, vanilla is on there as well. All of this has to be pollinated by bees. It's very, very useful for our own lives here. We wouldn't have all this stuff if it weren't for bees. Amazing. In fact, these beekeepers will travel around the country in a circuit loop, going around and pollinating all these different orchards and crops and fields so that we can actually have the food that we need to have on our planet. Now, the sad thing is, our bees are dying off. In fact, in the last 10 years, here in America, we've lost, they say, 1/3, maybe even a half of our bee population. And that's a lot. We're talking about billions of bees dying off. In the last, since I think it was 2003, they say that we've had over 3 billion bees die off. Just completely gone.
Wow.
We don't know exactly why they're dying off, but there are some reasons. There are things like pesticides that we're using, these neonicotinoids that we put in the seeds of plants that grow in the plant, and the plant actually produces these pesticides in their flowers, in their nectar, in their pollen, and it kills insects,
Wow.
and bees are insects. So when these bees take this pollen and they take it back to their colonies, and they store it, but then they eat it later on, it ends up devastating their entire colony. The other ways that we have kind of really done a lot of damage to bees are by the way that we grow food nowadays in America. It used to be 100 years ago, if you were a farmer, you raised all sorts of things. So you would raise corn, and you would raise cabbage, and you would have watermelon, you would have pear, you would have all sorts of variety of flowering plants. Nowadays, through farm consolidation, what we have are huge, huge valleys of food deserts. Imagine an entire valley, full of corn, something that the bees can't really eat and can't, doesn't produce a flowering plant for the bees. And so now the bees don't have wildflowers. We've cleared out fields of variety. We've cleared out fields and we have huge places of green, but the bees don't eat green. They eat the nectar. They eat the pollen. And so our farming practices have actually devastated the bees' ability to find food in a lot of places they go. So that's another one of the reasons why we're looking at this. And it's such a big problem that they've labeled it colony collapse disorder. And it's a problem that they've recognized in the United States, over in France, over in England. And in fact, in France, they've banned the use of these neonicotinoids, these pesticides that are ingrained within the seed. They've completely done away with it. And more recently, the National Park System, and I think it was 13 states now, no, 9 states, have now banned the use of these types of pesticides in the National Park System because they see that it's causing problems with bees. This was released, I think it was just last week that I read about that. But the disappearance of bees affects our economy, it raises our food prices because we don't have the food we once had. And it's such a problem in certain places of the world, like China, for example, where they've completely decimated local bees. They have no wild bees surviving there anymore in certain areas. It's become such a problem that now people are paid to hand pollinate every single flower. So they go up there with a little jar of pollen and a paintbrush, and they will dip that paintbrush in that jar of pollen, and they'll place it on every single flower. Kind of like, Alice in Wonderland, we're painting the roses red. They went through there and painted everything red because they had to get it right. That's what it reminds me of here, but these Chinese workers are actually in the trees pollinating by hand, and even with hand pollination, they only get about half the yield that the bees would be able to do. Can't do the job. But through the use of pesticides and the way that the Chinese have been farming and growing this stuff in certain regions, completely killed and decimated all the bee population. So now they have to go out by hand. Much more expense, much more laborious. And it's not even worth the yield, not even worth it. But they're having to do that to be able to survive. Bees are so important that even Albert Einstein recognized this problem long before we even saw that there was a problem with things like colony collapse disorder. And this is what he said. If the bee disappeared off the surface of the globe, then man would only have 4 years of life left. No more bees, no more pollination, no more plants, no more animals, and no more man. You see, our own existence is tied into these bees. Because without the bees, without the intelligent creators, the intelligent pollinators that God has created and put on this planet, we would not have the food. We would not have the things that we need in this life without these bees. But God, I believe, has ordained it in a way. He's given us incredible creatures in this planet that showcase His glory, that also help us in our lives through all the things we talked about, honey and the beeswax and the propolis and the various things that we have. It's incredible. Now, I don't want to take up all your night, so we can stop here if you want, or I've got maybe 15 more minutes. It's up to you guys.
15 more minutes.
You tired yet?
15 more minutes.
Go on.
All right, we'll go on. All right. That's a good place to stop, but we can continue here. Now, bees are so incredible, and when we study the life of bees, we continue to see that not only did God create bees, and they help us, and we're kind of mutually beneficial, but even in the animal kingdom, the way that God has created things in this world, there are things that we see that only bees can see and can be able to use. Things like these flowers that we see here. God has created these flowers with a central zone here that doesn't reflect ultraviolet light in the way that normal things do out there. And so as a human, we would view this flower like here, but a bee sees it with these black little bullseye target zones. And what these little target zones in the middle, therefore, are so that the bees can find the place in the center of the flower so that when they land, they know exactly where to go. They don't have to search around the flower and say, okay, here's the entrance, here's the middle, but they will see that, and it's a region of low ultraviolet reflectance where it doesn't reflect that UV ray, and the bees can actually see and can hone in on this invisible to us, this invisible area that they can actually go right there. It's a nectar guide that kind of guides them right into there. And they can quickly locate the flower center. So looking at the things around us, it's incredible. Even in the life of the bumblebee, you know, big fat bee that looking at it, we say aerodynamically the bumblebee should not even be able to fly, but yet somehow it does. The bumblebee itself is so incredibly important. It pollinates things that other bees can't even pollinate. For example, how many of you like tomatoes? All right. Anybody ever raised tomato plants? Okay. Tomato plants are pollinated by bumblebees. They're pollinated by some other bees too, but bumblebees have a way of pollinating tomato plants that no other bee has. You see, because the tomato plant is actually very sticky. If you ever worked with a tomato plant, you know that it's very sticky, it's tacky. Its pollen is also very sticky, and it wants to cling to the flower. It doesn't come loose very easily, unlike things like, lilies. You have Easter lilies, and the little pollen, and it gets all over your fingers, and it's a mess. Tomato pollen is different than that. It's very sticky. It stays with the flower. But the bumblebee has a trick. It flies to the tomato plant, it lands on that flower, and then the bee will actually vibrate its wing muscles without flapping its wings. It will vibrate its wing muscles at a perfect middle C frequency of a note. True story, not science
True
fiction.
story.
It vibrates itself in middle C, for those of you who love music, middle C, there you go. And this middle C actually produces the perfect harmonic resonance to shake loose this pollen that's stuck on there. Incredible. If it were a different note, a different pitch, a different vibration, it wouldn't shake it loose properly. But it produces what's called harmonic resonance, and it resonates that flower to be able to shake loose that pollen, and that bee is able to collect that pollen. Now, how do you suppose the bumblebee knows how to do this? I mean, wow. Millions of years of trying to get it right and failing. We wouldn't have tomatoes. But yet we do. So it gets on there, it lands, and it vibrates, producing this middle C buzz. This middle C buzz is very different from its normal buzzing as it flies around. And I want you to see this video because the bumblebee does this on all the flowers, even ones that don't need this buzz pollination is what we call it. But it's pretty incredible. You'll be able to see what this looks like and sounds like.